Okay, so you're back, and clearly you're as fascinated by the Mars rover as
Oh,
I
yeah,
am. I
absolutely.
mean, I don't blame you. I'm right there with you. And
It's incredible, isn't it?
today we're gonna really dig into the how behind this sci-fi movie level tech.
Right into the nuts and bolts.
Exactly.
Yep.
And we've got this document, Y5 Mars Rover 1K01.pdf,
Oh,
and
this is a good one.
it lays it all out. And the thing that just blows my mind
So it
is,
gets you as the distance, right?
oh, absolutely, like 350 million miles.
Can you even picture that?
No, not really. But the document puts it this way, which is kind of funny.
Let's hear it.
Okay, so they say it's basically like 9 billion double-decker buses,
Wow.
all lined up end to end. Like
That's a lot buses.
it's more buses than I can even imagine.
Makes our planet look tiny.
Totally. But the crazy thing is this rover, it's driving around on Mars.
Exploring all on its own.
And it's doing all this based on, well, essentially a language that only has,
2 letters, if you can call them that.
you mean like zeros and ones.
Right. Exactly. Binary code, the foundation of how computers think.
I remember way back in a computer science class I took,
Oh, you've all been there.
binary was like this super confusing thing.
It seems so simple, but
But the Mars rover, this incredibly sophisticated machine, is running on it.
it really is remarkable. And this document, I think it does a great job breaking it down.
Well, let's try to make sense of it together then.
Right. So first things first, let's just define a few key terms from the document here.
Okay, good idea.
So we're talking about data, which is all the information the rover collects, right? Then there's data transmission. That's how the data travels all the way back to Earth across millions of miles.
Millions of miles on zeros and ones.
It's mind-boggling. And then you've got input, which is the instructions scientists send to the rover, and output, which is what the rover does based on those instructions.
So it's like a super high-tech long-distance call.
And super important calls, too. We're talking about controlling a multi-million-dollar piece of equipment.
No pressure, right? But seriously, how does this actually work in practice? How do they tell a robot to, say, analyze Martian soil using just zeros and ones?
Right, well, that's where it gets really interesting.
Mhm.
Think of it like Morse code, but instead of dots and dashes, it's all about the pattern of zeros and ones.
I'm kind of following you.
Each unique sequence of those zeros and ones represents a specific instruction, and the rover's onboard computer has a kind of built-in dictionary that translates these sequences into actions.
Okay, wait, so the document here, it actually gives a table showing the binary values for our regular numbers 0 through 9.
Ah, yes, that's the key to understanding the whole system right there.
So is it like 00 doubled in means move 1 meter forward, and then some other sequence means take a picture or something?
You got it. But the beauty of binary is in its simplicity. Computers can process, store, and transmit binary information super efficiently, even over those vast distances we were talking about.
So the simplicity of binary actually enables the complexity of the entire Mars mission. That's pretty mind-blowing to me.
It really is. It's like the foundation of everything.
It makes you wonder, though, wouldn't a more complex language allow for even more sophisticated tasks? I mean, if they can already do this much with zeros and ones.
You're not wrong. There are definitely trade-offs. More complex languages require a lot more processing power and storage space. And you have to think about the rover's environment on Mars. It's harsh out there.
Yeah, dust storms, radiation, who knows what else.
Exactly. Binary is super reliable, which is key when you're sending signals millions of miles to a robot exploring another planet.
Okay, I'm starting to really grasp this. So binary, it's like the bedrock of this whole Mars rover mission, and it all boiled down to patterns of zeros and ones.
Precisely patterns that translate into instructions, which tell the rover what to do, how to move, where to go, what to analyze. It's all coded in binary.
This is like a whole new way of thinking about language.
It is. Think about it, the same language as zeros and ones. It powers our smartphones, our laptops, everything.
Well, it's everywhere.
And to think this all started with the idea of using just 2 simple digits to represent complex information?
It really makes you wonder, though, doesn't it? If we can achieve this much with just zeros and ones, what could we do with even more complex coding languages in the future?
The possibilities are endless. We might have rovers building habitats on Mars, mining asteroids, or even venturing beyond our solar system, all thanks to the power of code.
It's really an exciting time to be following space exploration.
Absolutely. The future is wide open, and it's all built on the simple but powerful language of binary.
Well, folks, there you have it. The Mars rover's incredible journey is made possible by a language with just 2 letters, 0 and 1. Pretty amazing, right? Who knows what incredible feats we'll accomplish next? Stay tuned, and we'll keep you updated on all the latest advancements in space exploration.
Until next time, keep looking up.
And keep exploring.